Hello YouTube. In my last video, I basically introduced the Fourier series, which is, like I said, a way to write a function in terms of an infinite sum of sines and cosines. Now, in this video, I'm going to derive what these are, what the coefficients and the constant are. It's not quite intuitive how to do it, but this is really important, so I try to only do things that I can really make intuitive, but this is an important thing that I need to demonstrate in order for some of my videos in the future. So basically, in order to start, how we're going to start is we're going to integrate both sides with respect to x from negative L to L. Because if these two functions are equal for all x, then if we integrate them over a certain bound, the value should be equal. So if we integrate this from negative L to L of f of x dx, that's going to equal the integral from negative L to L of c dx plus the sum from n equals 1 to infinity of, we can bring the integral inside because when we integrate sums, it's the same as the sum of the integrals. A of n is just going to be a constant for each n. So that's the a, we can bring that out, times the integral from negative L to L of cosine of pi n x over L dx plus b of n times the integral from negative L to L of sine of pi n x over L dx. Now, this is a great time to use what I showed in the previous video, where this is negative L to L of cosine of pi n x over L. N, we know, is always going to be a positive integer, so this is going to evaluate to 0 for all n's. This is sine of something times x, which is always going to be, which is an odd function, so the integral from negative a to a of an odd function, that's always going to evaluate to 0. Which means that the integral from negative L to L of f of x dx equals the integral from negative L to L. Well, actually, c is a constant, so we can bring that out, of c dx. We didn't really need to bring that out, but I'll do that anyway, which is going to be the same as cx evaluated from negative L to L, which equals 2cl, because that's a cl minus negative cl, 2cl. So now if we're trying to find c, we can divide 2l by divide both sides by 2l, and we'll get that c equals 1 over 2l times the integral from negative L to L of f of x dx. So now we have our c. This seems a little bit counterintuitive because it seems like you already need to know f of x as what it normally is in order to find this, but this is fine because we can do this. The problems that we need to solve usually don't involve finding this integral. So if we will usually already know this if we're trying to, we'll need to already know this in order to find that, which won't be a problem. Next, what we can do, this actually gets very complicated. What we're going to have to do now is multiply both sides of this function by a new function, kind of. Now we'll multiply both sides by cosine of pi mx over L. So that's going to equal c times the cosine of pi mx over L plus the sum from n equals 1 to infinity of a of n. This is basically a constant kind of in the n world, so we can just multiply both of these terms by that. N x over L cosine of pi m x over L plus b of n sine of pi n x over L sine of pi m x over L. Yeah. Now, we're going to set m because this is basically, we're just multiplying both sides by a thing, and because these are supposed to be equal for all x, this should always be correct. We can just multiply both sides by a thing. Now this thing, we're going to set this thing such that m is always an element of the positive integers. Again, m we're going to say is always an element of the positive integers. So now we'll integrate both sides like we did here from negative L to L with respect to x. So we'll get the integral from negative L to L of f of x cosine of pi mx over L dx equals the integral from negative L to L. Well, we can bring c out because it's just a constant. C times the integral from negative L to L of cosine of pi mx over L dx plus the sum from n equals 1 to infinity. A of n is just a constant. Times the integral from negative L to L cosine of pi nx over L times the cosine of pi mx over L dx plus b of n times the integral from negative L to L sine pi nx over L. Oh, this should be cosine. Whoops. Yeah, that should be cosine. I should probably be doing these videos in pencil. dx. There we go. Now that we have these, this we know from negative L to L, cosine pi mx, where m is a positive integer. We derived that like we said. This is going to evaluate to 0. This, we've got sine of pi nx over L, cosine of pi mx over L. Cosine we know is an even function. So that means that the cosine of negative x is going to be the same as the cosine of x. Sine we know is an odd function, so if we plug in negative x for there, that's going to be negative that. So sine of negative this, cosine of negative this is going to be the same as negative sine of this, cosine of this, which means this whole thing is an odd function, and therefore integrating it from a negative thing to the positive of that thing is going to just be 0. So this whole thing is also going to be 0. So now we have the integral from negative L to L of f of x cosine of pi mx over L dx equals the sum from n equals 1 to infinity of a of n times the integral from negative L to L of cosine of pi nx over L cosine of pi mx over L dx. Now, this is one of the reasons that this video is going to be so long, is because now we need to do this. So we'll just write it on a new line, and then we'll just figure out the integral. So integral from negative L to L cosine pi nx over L times the cosine of pi mx over L dx. Now, in order to do this, what we would basically do is integration by parts. Yeah, yeah, wait a minute. Integration by parts. Yeah. Now, in order to do this, we would basically use integration by parts, but to make it quicker, I'm just going to use tabular integration, because we would need to use integration by parts twice, and it'll be quicker just to use tabular. So we'll be differentiating and integrating, plus, minus, plus. It doesn't really matter which one we differentiate and which one we integrate, so I'll differentiate cosine of pi nx over L, and I'll integrate cosine of pi mx over L. So if we differentiate cosine of pi nx over L, it's negative sine of pi nx over L times the derivative of the inside, which is just pi n over L. It's going to be negative pi n over L sine of pi nx over L. There we go. And if we integrate this, it's basically going to be the integral of this divided by the integral of the inside. It's basically U substitution, but I'm not going to go through the whole thing. If you don't believe me, you can try it on your own. The integral of cosine is sine, so it's going to be L over pi m times the sine of pi mx over L. Now we want to differentiate this. We'll just do the same thing. This is basically a constant. Differentiate this. It's cosine, and then bring this inside out. So it's negative pi squared n squared over L squared cosine pi nx over L. And this thing, we'll do the same thing. This is basically a constant, integrating this. The integral of sine is negative cosine, so we'll get negative L squared over pi squared m squared cosine of pi mx over L. So what I'll do is I'll actually name this integral. We'll just call it I. Actually, I is only, it's a constant, but it's actually going to be different depending on what n is, so I'll call it I sub n. Now we know that this integral, which is I sub n, equals, we'll multiply diagonals, L over pi m cosine of pi nx over L sine of pi mx over L minus negative negative, two negatives are going to cancel out, minus this pi and that pi squared will cancel out to just one pi, one of the L's will cancel, so that's going to be minus L n over pi m squared sine of pi nx over L cosine of pi mx over L. Making sure, just checking myself. I tend to make strange mistakes like that. Okay, and then the next thing will be plus, the two negatives will cancel out, so plus, the L squareds will cancel out, the pi squareds will cancel out, the integral from negative L, because this last row is an integral to L. Oh, this is, by the way, going to be evaluated from negative L to L, this whole thing. Plus the integral from negative L to L of n squared over m squared cosine of pi nx over L cosine of pi mx over L dx. Now, if we plug in positive L, this sine x will turn into, the L's will cancel out, pi m is an integer, so that'll go away. Same with this, plug in the positive L, that's sine of pi n is positive integer, that will cause both of these to be 0. Plug in negative L, this is going to be sine of negative pi m is an integer, that will be 0, and plug in negative L, pi of negative, sine of negative pi n is an integer, that's going to cause this whole thing to be 0. So basically all of this whole thing is going to evaluate to 0. So I of n equals, and this is a constant, so we can bring it out, n squared over m squared times the integral from negative L to L of cosine of pi nx over L cosine of pi mx over L dx. Now if you'll notice, this is actually exactly the same as I of n itself. So then we have I of n, the equals n squared over m squared I of n. We'll subtract I of n from both sides, and we'll get 0 equals I of n times n squared over m squared minus 1. Now, we can basically, in order for the product of these two things to be 0, one of them has to be 0. So either I of n equals 0, or n squared over m squared minus 1 equals 0. We can add 1 to both sides, and we'll get that equals 1. Now, we know n and m are both positive, so therefore n over m has to be equal to 1, and then n equals m. So either I of n is 0, or n equals m. So that is very important to know. Now, what we can do with that is we'll rewrite this whole thing, and we'll get that the integral from negative L to L of f of x cosine of pi mx over L dx equals the sum from n equals 1 to infinity of a of n integral from negative L to L of cosine, actually, this we can just write as I of n, a of n, I of n. Now, what we can do is basically split this up. It's an infinite sum, so we can split this up as the sum from n equals 1 to m minus 1 of a of n, I of n, plus a of m, I of m, plus the sum from n equals m plus 1 to infinity of a of n, I of n. Because this is basically the sum, this is 1 plus 2 plus 3 all the way up to m minus 1, then we add m in there, then we get m plus 1 to m plus 2 to m plus 3, so this is just going to be the same thing, we're getting all of them. But in this case, the n is never going to be m, because it only goes from 1 to m minus 1, and in this case, the n is never going to be m, because it only goes from m plus 1 to infinity. So both of these, I of n is going to be 0, so we can cancel those out. And then we get that the integral from negative L to L of f of x cosine of pi mx over L dx equals a of m times I of m, which equals the integral from negative L to L of, we plug in m for n, so we're going to get cosine squared of pi mx over L dx. I'm running out of space a little bit, so I'm actually just going to kind of, I'm just going to have this little space to evaluate this integral, and then I'll use the next page for the rest. So now we know, so now we want to find out the integral, because basically what we, if n equals m, then I of n could be anything, because this is going to be 0. We have no idea what I of n is, so we have to evaluate it if n equals m. So we've got to evaluate the integral from negative L to L of cosine squared of pi mx over L dx. Now, how we would do something like this is using the double angle identity. So cosine of 2x equals cosine squared of x minus 1, 2 cosine squared of x minus 1. Add 1 to both sides, divide both sides by 2, and cosine squared of x equals 1 plus cosine of 2x all over 2. So this is going to be the same as, I'll bring out the over 2 to the outside, so this is the same as 1/2 times the integral from negative L to L of 1 plus cosine of 2 pi mx over L dx. And now we can split this up into 1/2 integral from negative L to L of dx plus 1/2 integral from negative L to L of cosine of 2 pi mx over L dx. Now this, even though it's written differently than what we saw before, this is 2 times an integer, which is still going to be an integer, times pi x over L. Now we evaluated that on the last page. We know that this, for any integer, is going to be 0. So this whole thing goes out. So then we know that this equals 1/2 times the integral from negative L to L of dx. That's going to be 2L. 1/2 times 2L is L. So if this whole thing is L, then we know that the integral from negative L to L of f of x cosine of pi mx over L dx equals L a of m, and therefore a of m, I'm just going to change the index back to n because it doesn't matter. We're about to evaluate what a of m is, so if we just replace all the m's for n's, we'll find out what a of n is. So a of n equals 1 over L times the integral from negative L to L of f of x cosine of pi mx over L dx. Now we've got c right there, and we've got a of n, nx, and that should be an n over L. There we go. So we have c and we have a of n. Now all that's left is b of n, and we're going to do it in very much the same way. I could probably use this result to find b of n, but I'm not exactly sure how I would do it, and I think it would be more helpful to just derive the whole thing, to let everybody see exactly how you would do that if you decided to do that first. Alright, now we've just derived these two, so now all that we have left is to derive b of n. And now if we multiplied both sides by cosine of pi mx last time, this time we'll multiply both sides by sine of pi mx over n. So then we'll get f of x sine of pi mx over L, I think I was saying n, I meant L, equals c sine of pi mx over L plus the sum from n equals 1 to infinity of a of n cosine of pi nx over L sine of pi mx over L plus b of n sine of pi nx over L sine of pi mx over L. I'm just going to draw a line to separate those two. Okay, and parentheses there. Now we want to, just like last time, integrate both sides with respect to x from negative L to L. So the integral from negative L to L of f of x sine of pi mx over L equal dx, don't forget the dx, is, c is a constant, so we'll bring that out, c times the integral from negative L to L of sine, and just like last time, I'll just write down again, m is an integral, is an element of the positive integers. So that, the integral from negative L to L of sine of pi mx over L dx plus the sum from n equals 1 to infinity of a of n times the integral from negative L to L cosine pi nx over L sine of pi mx over L dx. I think I'll write it here, plus b of n times the integral from negative L to L sine of pi nx over L sine of pi mx over L dx. Now, this is going to be an odd function. Sine of something times x, that's an odd function, from negative a to a, 0, like last time. This part's an odd function, this part's an even function. Even function times an odd function is an odd function. That's not too difficult to prove, but we can basically see, plug in negative x there, it's going to be the same as positive. Plug in negative x there, you'll bring a negative outside. Therefore, that's going to be, this is an odd function, so this is going to also evaluate to 0. So then we have the integral from negative L to L of f of x sine of pi mx over L dx equals the sum from n equals 1 to infinity of b of n sine, times the integral from negative L to L of sine of pi nx over L sine of pi mx over L dx. And now, just like last time, we got to evaluate that. So integral from negative L to L of sine of pi nx over L sine of pi mx over L dx. Tabular integration again, plus minus plus sine of pi nx over L sine of pi mx over L. Then differentiate that, bring out pi n L, pi n over L cosine of pi nx over L. Derivative of sine is cosine, derivative of the inside, pi n over L. And this part will do the integral. Integral of sine is negative cosine, and divide by that, negative L over pi m cosine of pi mx over L. And then derivative of this again, derivative of cosine is negative sine. We're going to take the derivative of the inside also. Negative pi squared n squared over L squared sine of pi nx over L. And this one, the integral of cosine is positive sine. Then we'll divide by the inside, so then it's going to be negative, because we still got that negative there. L squared over pi squared m squared sine of pi mx over L. So now we'll call this j of n, because we called the last one I of n. So then we know j of n equals negative L over pi m sine of pi nx over L cosine of pi mx over L minus, this one's actually going to be a plus because there's no minus there and there's there to cancel out, L squareds will cancel out with 1L. One of the pi's will cancel out, the n and then the m squared. Cosine of pi nx over L, sine of pi mx over L. Then these two negatives will cancel out, plus the integral from, and again, forgot again, this whole thing is evaluated from negative L to L. The integral from negative L to L of the pi squareds will cancel out, L squareds will cancel out, n squared over m squared, sine of pi nx over L, sine of pi mx over L dx. Now, you know the drill, L plugged in there, this is going to be an integer times pi. That whole thing is going to evaluate to 0 for L and negative L. This one, integer times pi, evaluate to 0 for L and negative L. So this whole thing is again going to be equal to 0. And we can bring this to the outside because it's a constant. J of n is n squared over m squared. It's the integral from negative L to L of sine of pi nx over L, sine of pi mx over L dx. This, as you recognize, same as J. J of n equals n squared over m squared J of n. So therefore 0 equals J of n times 1 minus n squared over m squared. So either J of n equals 0 or 1 minus n squared over m squared is 0, therefore 1 is n squared over m squared. Multiply both sides by m, square root both sides because both of these have to be positive. N over m is 1, multiply both sides by m equals n. One of these things is true. It's the or symbol. So either J of n equals 0 or m equals n. Now we can rewrite this part in the same way that we did before. Integral from negative L to L of sine of pi nx over, integral from negative L to L, I was looking at the wrong line, of f of x sine of pi mx over L dx equals the sum from n equals 1 to infinity of b of n, I of n. That's I of n as we've defined it. Now we can do the same thing that we did last time, integral from negative L to L of f of x sine of pi mx over L dx equals the sum from n equals 1 to m minus 1 of b of n, I of n, plus b of m, I of m, plus the sum from n equals 1 of m plus 1 to infinity of b of n, I of n. In this case, n will never be equal to m. In this case, n will never be equal to m. So both of these are going to be 0. So then the integral from negative L to L of f of x sine of pi mx over L dx equals b of m, I of m. Now we have to evaluate I of m because, as last time, if n is not equal to m, if n equals m, then J of n could be anything. So we'll say I of m equals the integral from negative L to L. If n equals m, this is just going to be sine squared of pi mx over L dx. Now, using the double angle formula again for cosine, cosine of 2x can also be written as 1 minus 2 sine squared x. Subtract cos 2x and add 2 sine squared x from both sides, and then divide both sides by 2. You get 1 minus cosine of 2x over 2 equals sine squared of x, which means I of m equals the integral from negative L to L of 1 minus cosine of 2 pi, actually, I'll write it like I did last time. I of m equals 1/2 integral from negative L to L of 1 minus cosine of 2 pi mx over L dx. Now we can split that up, so I of m equals 1/2 integral from negative L to L of dx minus 1/2 integral from negative L to L of cosine of 2 pi mx over L dx. M is an integer, 2m is also an integer. This is an integer times pi times x over L, evaluated from negative L to L. We know that this is 0. So that means I of m equals 1/2 times this, that's going to be 1/2 times 2L, which is going to be L. Therefore, integral from negative L to L of f of x sine of pi. I'll switch the, actually I'll keep it, I'll switch it on the next line. Dx equals b of m times I of m is L. Then we'll divide both sides by L, and we'll change the index to n. So 1 over L times the integral from negative L to L of f of x sine of pi nx over L dx is b of m. Okay, so we've just demonstrated that c is 1 over 2L times the integral from negative L to L of f of x dx. A of n, the coefficient of the cosine term, is 1 over L times the integral from negative L to L of f of x cosine of pi nx over L dx. B of n equals 1 over L times the integral from negative L to L of f of x sine of pi nx over L dx. So we're basically done. We can write this a little bit better though, because actually what we can see is if we find a of 0, there's never going to be a of 0, because this is only going from 1 to infinity. But if we plugged in 0, we would get pi times 0 times x over L. The 0 is going to cancel everything out, so that's cosine of 0. Cosine of 0 is 1, is f of x. So this cosine of 0 is 1, multiplied by f of x is just f of x. So a of 0 is going to be 1 over L times the integral from negative L to L of f of x dx. So if we divided a of 0 by 2, we would get 1 over 2L times the integral from negative L to L of f of x dx, which means that c is the exact same thing as 1/2 a of 0. So then what we can write a of f of x is, we can write f of x as the f of x, the Fourier series of f of x is going to be 1/2 a naught plus the sum from n equals 1 to infinity of a of n cosine of pi nx over L plus b of n sine of pi nx over L, where a of n and b of n are right there. We could write this all in one line, but because it would get pretty messy to write a of n and b of n in there, we usually write it like this and then write a of n and b of n separately. But yeah, so this is the formula for the Fourier series of a function f of x. It's very helpful when it comes to describing strange periodic functions, because we can just write them in terms of cosines and sines, which are much easier to work with in a lot of different cases. And we can also use it to we can write functions, even if they are easy to deal with, we can write them in a different way that can then help us solve different problems. So yeah, this will be very useful to us in the future.